Ladies and gentlemen, I want us to have a look at the domain of radical functions. Now, in our previous video, we look at how to find the domain of a function. And there were two rules that we were considering. Number one is that we cannot divide by zero. An expression divided by zero is undefined in the real number system. Number two, we said that we cannot take the square root of a negative number. Now, again, we looked at radical functions, and we said that radical functions are of this form. That is, it has an expression under the root sign. It has an expression under the root sign. Again, we said that when n is odd, for example, let us consider the cube root of 27. The cube root of 27 is just 3, and the cube root of negative 27 is just negative 3. The two are real numbers. 3 and negative 3 are real numbers. Therefore, we can conclude and say that the domain of radical functions with an odd index is all real numbers. We conclude and say the domain of radical functions with an odd index is all real numbers. Now, let us also look at when n is even. When n is even, for example, square root, 4th root, 6th root, 8th root, and so on. When n is even, this expression that is under the root sign must be greater than or equals to 0. To find the domain of radical functions with an index that is even, that means we shall take the expression under the root sign, and the expression must be greater than or equals to 0. This expression that is under the root sign when n is even should be greater than or equals to 0. Now, let us find the domain of this function. This is f of x equals to the square root of x minus 9. Now, considering the two rules, especially the second rule, because the first one is that we cannot take, the first one says that we cannot divide by 0. And in this case, we don't have a fraction. The second rule says that we cannot take the square root of a negative number. And in this case, we have the root sign. And therefore, we consider the second rule, because the first rule is not applicable here. That means we take the expression that is under the root sign, which is x minus 9, and it should be greater than or equals to 0. And in this case, our x will be greater or equals to positive 9. If that is the case, then the domain of this function is a set of all real numbers that are greater than or equals to 9. It is a set of all real numbers that are greater than or equals to 9. That means 9 is included. And if we represent it using a number line, then we shall have, this one is a number line. We have from negative infinity, we have 9 here, we have positive infinity. So because this one is greater or equals to, that means we shall shade here, that is, we shall shade the point where 9 is, then it is greater, so it goes that way. All values that are greater than 9 or equals to 9. So that means this dot means 9 is included. in interval notation, because 9 is included, I just write it this way, then 9 comma positive infinity. This one is in interval notation. Now let us have a look at this second example. Now in this case, we have f of x equals to the square root of this quadratic expression. Now how do we find the domain of this function? This is what we shall do. Because the first rule says that we cannot divide by 0 and this one is not a fraction, the second rule will apply here. Because the second rule says that we cannot take the square root of a negative number and this one is a square root sign. And therefore in this case, the expression that is under the root sign, must be greater than or equals to 0. It must be greater or equals to 0. And this one, we can factorize this quadratic expression. And if we factorize it, in this case, the sum of two numbers should give us the coefficient of x, which is 4, and the product of two numbers should give us negative 21. Which two numbers, when we add them, we get positive 4, and when we multiply them, we get negative 21. The two numbers can be negative 3 and 7. That is negative 3 and 7. Now, that means we shall have x minus 3, then we close the bracket, then x plus 7 equals to, not equals to, but greater or equals to 0. Now, in this case, we can ignore this inequality sign, and therefore x minus 3, close the bracket, x plus 7 will be equals to 0. And in this case, we shall have x minus 3 is equals to 0, or x plus 7 equals to 0. Now in this case, x will be 3 or negative 7. Now let us represent this on a number line. We shall have, that is from negative infinity, we have negative 7, and we have 3. Then we have positive infinity. Now, I want us to consider numbers that are to the left of negative 7 and numbers that are between negative 7 and 3, and also numbers that are to the right of 3. And check if they are greater than or equals to 0 if we substitute those values in this expression. Now, any number that is to the left of negative 7 is negative 8. Therefore, we take x equals to negative 8. And a number that is between negative 7 and 3, we can take 0 because it is between negative 7 and 3. A number that is to the right of 3 is 4. And therefore, these are our 3 test points. We want to see whether at this point or to the left of negative 7, will we get a number that is greater than or equals to 0, or we get a result that is greater than or equals to 0? The same applies to x equals to 0 and to x equals to 4. Now, let us substitute x with negative 8. So we shall have negative 8, then minus 3, then we close the bracket, then we have negative 8 plus 7. We close the bracket. What do we obtain? Negative 8 minus 3, it is negative 11. Negative 11, then times negative 8 plus 7 is negative 1. So negative 11 times negative 1 is positive 11. And 11 is greater, it is greater than 0. And in this case, it is positive at this point. The answer is positive. Now, when x is 0, if we substitute x equal, that is x with 0 at this point, that means we shall have 0 minus 3, which is negative 3. Then 0 plus 7 is 7. And in this case, we shall have negative 21. So when x is 0, that means between negative 7 and 3, it is negative at this point. Now, between, that is 3, to the right of 3, we have positive 4. If we substitute x with 4, will we obtain a positive or a negative number? So if we substitute 4 here, what do we obtain? We shall have 4 minus 3, then 4 plus 7. And in this case, we shall have 1 times 11, which is just 11. So in this case, we shall have a positive answer. So to the right of 3, we shall have positive. Between negative 7 and 3, it is negative. Then to the left of negative 7 is positive. Now, ladies and gentlemen, in this case, these are our test points. Now, when we tested them, we found that when x is negative 8, we obtain a positive answer, which is positive 11. And our interest is to obtain an answer that is greater than or equals to 0. So in this case, this one satisfies. So that means the x values that are less than negative 7 are required. Now, let us also consider when x is 0. So when x is 0, we obtain a negative answer, of which our interest is to obtain an answer that is greater than or equals to 0. And in this case, this one is not required. X equals to 0 is not required. That means all the values of x that are between negative 7 and 3 are not required. Now, when we see the value that is to the right of 3, and that is 4, we tested it and we obtain a positive answer, which is required here because the answer, that is 11, is greater than or equals to 0. It is greater than, in fact, 0. And our intention was to obtain an answer that is greater than or equals to 0. That means the domain of this function is real numbers that are less than negative 7, less than or equals to negative 7, and also real numbers that are greater than or equals to 3. That is the domain of this function.